Okay, guys, let me see if I can zoom this a little bit more for you here. Oh, there you go. So we just needed to finish up our notes, which we didn't quite finish yesterday. Before this, we had talked about scientific notation, right? And we did a little bit of mental math there. And again, your quiz problems will be much easier than the ones that were on the actual assignment here. So we'll keep, the numbers out in front. We'll keep to whole numbers and not decimal numbers here for you. But you should know how to go from scientific notation to regular notation, from regular notation back to scientific. If you get one that's not really in correct scientific notation, we should be able to fix that. So again, 385 times 10 to the fifth, we need to decrease that 385 down to 3.85. So that means we had to move the decimal point 2 places. So this exponent is then going to go up by 2. If I decrease this number out in front, then I'm going to increase the exponent. And the reverse would be true as well. If I needed to increase the number out in front, I would decrease the exponent. So being able to make those changes is important as well. Before that, we talked about SI units as well as derived units and kind of knowing the difference between those. So let me get back down here. So the only part we really had left was dimensional analysis, and I was kind of up in the air whether or not to take a day to do dimensional analysis with you guys, because I think most of you are good with it. However, with the math pre-test, not all of us were showing it, and so I wasn't really 100% certain. And so we do need to be really good at this. And so I figured we'd go ahead and take a day and make sure that we were good here. So kind of the general approach here when you're doing dimensional analysis is to start with identifying what it is you're starting with, what your equivalent statements are that you're going to need, and then what you're looking for. Because ultimately, all three of those things are what you bring together to complete your problem in dimensional analysis. And then step 2, you write out that starting quantities, and then you multiply by fractions that express your equivalences so that the units cancel out. And how do you do that? So whatever unit you're starting with that you want to get rid of, that unit then has to be on the bottom of the next fraction, and the unit that you're trying to go to should be on the top of that fraction. And then sometimes we need to chain those fractions together so that we can go from a unit that we know it might take us several steps to get to the unit we want, using the equivalent statements that we know of. And so we'll see some examples of those chained together here in the practice problems. And then step 4, the result should have units for the quantity that we're looking for. So the final answer should have the units that we're wanting to solve for. So real quick, metric prefixes that I would expect you to know here, not really any different than chemistry level with the exception of probably mega and micro. There's a couple more that may come up by the end of the year, including pico and nano, and if those come up, we will deal with those when we get to them. So mega is 10 to the 6th, and so that means that if you have a megameter, for instance, 1 megameter is 10 to the 6th base units. And so base units are, give me a second here, I'll just put BU for base unit here. And so the base unit, if we're talking about megameters, the base unit is meters. And so 1 megameter is 10 to the 6th meters. 1 kilo as a prefix is telling me 10 to the 3rd of my base unit. Hecto is 10 to the 2nd of my base unit. Deca is 10 to the 1st of the base unit. Again, it's telling me that 1 decameter, for instance, is 10 to the 1st meters. Then here is where our base unit would be, whether that could be grams, that could be meters, that could be liters, that could be amps, that could be any of my SI base units. Deci is 10 to the negative 1. So again, this is 10 to the negative 1 base units. So again, if I have 1 decimeter, it is 10 to the negative 1 meters, and that would be an equivalent statement. If I have 1 centimeter, that's 10 to the negative 2nd meters. Okay. If I have 1 millimeter, it's 10 to the negative third meters, and 1 micrometer is, again, 10 to the negative sixth meters. And so understanding them in those terms, I think, makes it a little bit easier. It's always the base unit that your power of 10 goes with, and it's always equal to one of your other units. And again, there's a nice pattern here, 1, 2, 3, 6, and -1, -2, -3, -6. And again, hopefully you should have kilo, hectodeca, deci, milli. Hopefully you got those memorized already. And so really this year we're just adding in mega and micro to that mix and kind of expanding those prefixes. Those of you that are seniors getting ready to go into college, science next year, they don't add too much more onto that. They probably add 10 to the 9th, maybe 10 to the 12th here, and definitely 10 to the negative 9th, 10 to the negative 12th down there. And so let's take a look at some examples here. So 72 eggs is equal to how many dozen? So we start with what we're given, which is 72 eggs. I need to multiply it by an equivalence statement that relates eggs to dozens, if I know it. In this case, I do. 1 dozen is equal to 12 eggs. And so I'm either going to multiply it by 1 dozen over 12 eggs or 12 eggs over 1 dozen. The only way I can get eggs as a unit to be eliminated is if I put eggs on the bottom. Okay, so the same way as if I'm doing math and I have a 5 on top of my fraction and a 5 on the bottom, they would cancel. Or if I have an x on the top and an x on the bottom, I could cancel them. The same thing happens here with units. If I have eggs on top and eggs on the bottom, those can cancel. And again, any number by itself, remember, is the same as that number over 1. So eggs would cancel here. I'd be left with dozen as the unit, and that's the unit I want to go to. So I know I'm done here. And so then I just do the math, multiply across the top, 72 times 1, divide by things on the bottom, divided by 12, and I get 6 dozen. 1.6 days is equal to how many seconds? So the number of steps here, again, this is one where we're chaining these fractions together, but your number of steps depends on what equivalent statements you know. So I know that 1.6, somehow I get 6-1 there. Sorry, 1.6 days is, I can go from days to hours. I know that equivalent statement. I know that 1 day is equal to 24 hours. I've got the days on the bottom, hours on the top. I'm still not there yet. I want to be in seconds. So I know that 1 hour is 3,600 seconds. And so I'm able to use that as an equivalent statement. And I just multiply 1.6 times 24 times 3,600. And I'm going to end up with my answer. Okay, my measurement here was 1.6, had 2 significant figures. So notice my answer there has 2 significant figures as well. Give me 1 second here. I'm going to double check that answer since I had to make a correction. And 4, 2, 3, 4, that is correct still. So, and if you didn't know that 1 hour is 3,600 seconds, number one, I would say probably memorize that one because that one's going to be really useful in physics. But it's okay if you don't, because you should know that 1 hour is 60 minutes. And then you could add another fraction here, which is 1 minute is equal to 60 seconds. And then you'll still get the same answer. 950 grams is equal to how many kilograms? And so I start with the number I'm given, 950 grams. I need an equivalent statement that's going to relate grams and kilograms. And again, from up here, here's my kilo prefix. So I know that 1 kilogram is equal to 10 to the third of my base unit. My base unit there is grams. So I know 1 kilogram is 10 to the third grams. And so again, I want the grams on the bottom, so they cancel. So 1 kilogram is equal to 10 to the third grams. So I take 950 divided by 10 to the third, and I get 0.95 grams. 2.51 kilometers or kilometers is equal to how many centimeters? So I take 2.51 times 10 to the third meters over 1 kilometer, and I get 2,510 meters. Again, my kilometers cancel here, and I'm left with meters. 781 inches is equal to how many meters? So 781 inches times, I know that 1 inch is 2.54 centimeters. Again, that's a really good one to memorize if you don't have that one down yet. I'm in centimeters now, so I can go from centimeters to meters. using that prefix centi, I know that 1 centimeter is going to be 10 to the negative second of the base unit, which in this case is meters. I can do my multiplication here, 781 times 2.54 times 10 to the negative second, and I'm going to get 19.8 meters. Again, rounding that for significant figures. 32 square centimeters. How am I going to do that? So I know that 1 inch is equal to 2.54 centimeters. So if I multiply by that, remember centimeters squared is really just centimeters times centimeters. So I would be able to cancel out one of my centimeters, but not both of these centimeters. And so I would end up with an inch over or an inch times a centimeter. And that's not the unit I want. I want square inches. So I need to do that conversion one more time. And so I have 1 inch over 2.54 centimeters again. The second centimeters will cancel the second centimeters here that I started with. And so now I would end up with inches times inches on the top, which is inches squared. And so I do the math there and round for significant figures. I'm going to get 5.0 square inches. 9.8 meters per second squared is equal to how many feet per second? So I've got 9.8 meters over 1 second squared. And so I want to get rid of, it looks like I'm changing my meters to feet. My second squared is staying the same. So I know that 1 centimeter is 10 to the negative second meters. My meters would cancel. I'd be at centimeters per second squared there, so I'm not quite there yet. I can take centimeters and change it to inches using 1 inch is equal to 2.54 centimeters. And then I would be at inches per second squared, so not there yet, but almost. And I know that 12 inches is equal to 1 foot. And so the inches cancel there. I'd be left with feet per second squared, which would be 32 feet per second squared. 3.0 times 10 to the 8 meters per second. If I want to take that to miles per hour, okay, I would start off with 3.0 times 10 to the 8 meters over seconds. I know that I want to change my seconds to hours and I want to change my meters to miles. And so this one's a little bit lengthier of a problem. And so I'm going to change my time first. I could have started with changing the meters to miles. Either way is fine. But I chose to change my seconds to hours first. So I know that 3,600 seconds is equal to 1 hour. I put the seconds on top because I started with seconds on the bottom, and as long as one's on the bottom, one's on the top, I can cancel seconds. I would be left with hours. And notice I want hours on the bottom at the end, and so I'm done converting the time. So then I've got to convert my meters into miles, and so I know that 1 centimeter is 10 to the negative second meters. So I would be at centimeters per hour if I stopped there. So I need to take my centimeters and I can change it to inches. So I know 2.54 centimeters is equal to 1 inch. Again, if I stopped at this point, I would be at inches per hour. Not quite there yet. I know that 12 inches is equal to 1 foot. And so I would be at feet per hour there. And then if it told me that 5,280 feet is equal to 1 mile. And so that gets me 2 miles per hour, which is where I want it to be. Again, round for significant figures. Once you do the calculation, multiplying by 3,600, dividing by 10 to the negative second, dividing by 2.54, dividing by 12, and dividing by 5,280. And I get 6.7 times 10 to the 8th miles per hour. Couple word problems on the side, a little bit different on these. These are using different rates to make conversions. So we did this last year when we did density, when we used density as a conversion factor. And there was a couple other instances where we used this, but I wanted to show you a couple other examples of that. So a 2008 Toyota Corolla has a 13.2 gallon fuel tank and averages 29 miles per gallon. So there is a conversion factor right there that I might be able to use in the problem. It's 29 miles is equal to 1 gallon, right? If the price of gas is $3.72 per gallon, so there's another equivalent statement, $3.72 is equal to 1 gallon, right? What is the price of gas spent to drive 28.1 miles to Disneyland? So there's my given value. So I know I'm starting with, I have to drive 28.1 miles. And then I can use my conversion factors that I got from, or my equivalent statements that I got from the problem. I know that 29 miles is equal to 1 gallon. That would get rid of my miles and give me gallons. And then I know that 1 gallon is $3.72. So again, that would get rid of my gallons and leave me with dollars. And that's what I wanted. I wanted what price of gas was spent to drive that distance. And so I take 28.1 divided by 29 and then times the 3.7 or $3.72. And I end up with, if I round for significant figures, $3.60. And that's a perfectly acceptable answer here. In reality, if you're going to make it to Disneyland, you actually must round up, because if you rounded down and only spent $3.60, you wouldn't quite make it. So if you logically see that step and you put $3.61 in a problem like that, I would be perfectly fine with that. Okay, if you didn't, then that's fine too, if you just rounded for sig figs. So Sam weighs 120 pounds on Earth, but weighs 20 pounds on the moon. If Chris weighs 25 pounds on the moon, how much does Chris weigh on Earth? And so what we're starting with here, we want to know how much Chris weighs on Earth. So that's what we're finding here. Another typo here. Give me 1 second here. It should be Earth. So we know our given information is that Chris weighs 25 pounds on the moon, right? And we know that 20 pounds on the moon is equal to 120 pounds on Earth. So that information about Sam represents an equivalent statement. And so I know 20 pounds on the moon is equal to 120 pounds on Earth. I want to put my 20 pounds from the moon on the bottom so that the pounds on the moon cancel, and I'm left with pounds on the Earth on top. Okay, so I take 25 times 120 divided by 20, and I would end up with 150 pounds on Earth. All right, guys, I hope that was a good review. I hope it helps if you struggled with dimensional analysis next year or last year. It's my hope that things start to click for you this year. We do have a worksheet to do with dimensional analysis, and so I'm going to let you get started on that early today. Unless he's sick, Graham will be there. He certainly can help with dimensional analysis. And then I will post an answer key for the homework. Again, I caution you, don't look at the answer key until you're sure you can do all of them. And you can't be sure of that unless you try all of them without looking at the answer key. It's very easy to read through an answer key and be like, oh yeah, that's what I would have done. In reality, though, oftentimes you do not. I think it's really important in both chemistry and physics especially that you get some immediate feedback on whether or not you're doing it right? A lot of you struggled last year with that because you weren't sure if you were getting the right answer or not. And so this year I'm posting the answers early, but there's some responsibility on your part to use them wisely and use them the way they're meant to. The result of not using them that way would, of course, be that come next week when we do our quick check and then ultimately our quiz, you won't quite be ready for it and you won't understand the material well enough to show it on the quiz if you just pull up the answers and copy them down. And so those are kind of real world consequences for those things. And so it's my hope that you don't do that. And I understand students get busy sometimes and you might do that at times, but I would strongly encourage you to limit that as much as you can and not do that. So if you do problems and they don't make sense and you go to the answer key and it doesn't make sense still, that is the time when you need to get help. Whether that's from, again, if you're in class tomorrow and Graham's here, you certainly can ask him. But if he's unable to help you, or if for some reason that's not perfectly clear for you, then definitely shoot me an email or a text through the Remind app. We can try and clarify it that way immediately or as soon as I can get to the message. And then if not, then come and see me Monday morning and we'll get it figured out then. I hope you have a great weekend. Enjoy Corn Festival. Be safe, and we will see you on Monday.